The particular thing that you have in, that I have right here, I did not choose to print it for you. It is online. If you want it, feel free to grab it. It's there. But there's a list of things, a process that you kind of pass through, and hopefully this makes sense. So in related rates problems, the first thing that you always do is make a sketch. Have we done that so far? Every single time. In fact, a lot of times that sketch is already provided for you when you start the problem. But if it's not, make one, okay? And then we're going to label all those sides. And a really, really important thing is to pay attention to what is going to change in the problem and what is going to stay the same. Is that cool? You're going to pay attention to what changes and what stays the same, because constants are your friend. Now, one thing that is really kind of important is this part right here, is in the problem, you're going to pick a convenient variable of your choice. So if you're going to be talking about volume, what have we done?
Can you share your screen, Mr. Brenner?
Sorry, did it not share? Sorry about that. When we look at that, like what would we use for volume? dV dt. Now, what's a little awkward is sometimes you're in a situation where it's the distance that's changing. And so you might call it dd dt, but that sometimes feels really awkward to do. And so sometimes instead of using d for distance, you might just call it a, b, and c or something. We did that in here earlier as well. Okay, so you want to make sure you label all of them. And you should notice that if it's increasing, your derivative should be positive, and decreasing, your derivative will be negative. Sometimes the way the problems are listed, they don't explicitly tell you positive or negative. They talk about things increasing and decreasing, right? So identify the snapshot moment. We've done that because remember we talked about, hey, we did the ice cream cone and it said at the moment when the radius is this, what happened, right? There's a snapshot moment. That happened when? When do we use that snapshot moment? Is it before or after we do calculus? It's after. That snapshot moment happens after the calculus. So you'll notice that we made a sketch, we took our derivative, we labeled everything, then we look at our snapshot moment. So as you go through all of those things, you'll notice that Mr. Corpy, again, multiple times mentions this idea of looking for constants, because why are constants such a happy thing for us? Because what happens when you take the derivative of a constant? You get 0, and that makes a big portion of the calculus go away, doesn't it? So I put a list of all those things. Some of you guys really like these things to kind of do that, but this looks like a lot for me, for you guys to read through. But if it helps you to kind of, as you're studying for a test, like what are the processes that I go through, again, a little bit Maximus. But the last little step right here is you are always, and again, this is partially because I know some of us will be taking AP, but a lot of you will be going off to college. In these problems, they are word problems, and the standard on any word problem when you're done is you just don't write like 3 and smile and move away. In a word problem, you write a quick sentence saying what it is that you have found. Like a little bit of it, and I know you like the smile part, but that's just kind of what happens. So what my plan to do today is to go through a couple of problems. So, and I know that I'm showing you something that I did not print for you because frankly, there's only so many copies that I want to run. So you guys can sketch down what is actually necessary in this, but you don't have to write down all of the verbiage. But I wanted you to see that the first question that we have in front of us right now, look what it says. It says 1984 AB5. What is that showing you? What do you think that stands for? 1984, the year 1984, AB 5. This is a released AP test question from 1984. It was question number 5 off of that test. So it turns out right now I haven't given you any released AP questions yet because it wasn't until basically now that we've actually done enough calculus, because the way they usually do those problems is you need a few different pieces. And we've now established every kind of derivative we could take. And so we can now do some. So we've got a volume of a cone is increasing at 28 pi cubic inches per second. So tell me, what did they just tell me? It says the volume of the cone is increasing at 28 pi cubic inches per second. They gave me dV dt, so we should probably identify that and write that down. So for A, we have that dV dt is 28 pi inches cubed per second, okay? At the instant when the radius of the cone is 3. Now, what is that? Is that the constant value or is that a snapshot value? That's a snapshot. When am I going to use that then? After I do calculus. So R equals 3 inches. At that instant, its volume is 12 pi. And the radius is increasing at 1/2 of an inch per second. dr dt is equal to 1/2 of an inch per second. So I get tricked by this myself quite frequently, so just be a little bit careful about that when we look at it. I got to be really careful because sometimes I get hooked on units a little bit. Do they play games with units here? Look at it. Inches, 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 seconds, seconds. Are we doing okay? They didn't actually do anything to kind of mess with my brain on that one. So we've got this picture over here. Let's draw it. So it's a cone, right? And you might be thinking about, like, how would you make a cone grow? Well, the easiest thing is you just have a bigger cone and you start filling it and you've got a growing cone inside. So what would I label this as right here? In general, that would be H, isn't it? What else am I going to label? The radius, that's going to be right here. I've got H, I've got R. Now, as that cone fills up, and I go like this, see it's filling like this, what will happen every single time as you fill that up? What would happen? The height and radius will change, but they will change very specifically in a constant ratio. They will grow together. If the height doubles, what's going to happen to the radius? It's going to double. If the height triples, it's going to triple. It just has to. We have this kind of story. So now, we've got some information over here, and it says, okay, so at the instant when the radius is 3 inches, what is the rate of change of the area of the base? We haven't done that before. What shape is that base? It's a circle. So do we have a master formula for the area of a circle? Yeah, we do. What is A? Pi r squared. So if we now have our geometry formula, we have a diagram, we figured it out, we've identified all of our stuff. What's the derivative? dA dt. dA dt equals 2 pi r dr dt. Now, let's read carefully. What do we know? It says, at the instant when the radius of the cone is 3 inches. Oh, what did they hand me? R. Did they also tell me dr dt? Ooh, so I've got it. It is 2 times pi times r times dr dt. Hey, that's pretty cool. Did I get everything I needed? I think I got it. So what does that come out to? I think we got 3 pi. Careful about this. What's the units on it? What is changing? Well, what is changing? Is dA dt would be the rate of change of the area. So what unit should I have if I'm right? Inches squared per second. Hey, you guys just did your first AP question. By the way, doesn't that seem like a little bit more like digestible than some of the crud that they throw at you in like a biology class? I feel like calculus is really very well defined. If you know what you're doing, will they sometimes trick you? Absolutely, but there's quite a few questions you're like, oh yeah, I got that, I know what to do. So let's look at B. It said, at the instant when the radius of the cone is 3, what is the rate of change of its height? So how am I going to relate the radius and the height together? Well, I'm going to have to do that through the volume. So the volume is 1/3 pi r squared h. Now that is one thing that they didn't used to do, but they tend to do now. They did not used to hand you formulas like this. You'll notice it wasn't here, was it? Anymore, they tend to do that, and part of that is because when we switched over to Common Core, we've de-emphasized geometry a lot, and so a lot of students can handle the geometry. They just haven't done that much of it, so they don't have them memorized. So I've got a little bit of a problem here because I know what the radius is, but what do we not know? What the height is. So let's go back and reread because there's something that was missing up in that top that we didn't need until now. And this does happen on AP tests. You're going to go through and they gave you some information that you don't need, but you need it later. It said when the radius was 3, it said the volume was 12. Can I use the radius and the volume to figure out what the height was at that moment in time? So I got that snapshot. That's what I needed to do. So according to this, as that snapshot, the moment when the volume was 12 pi cubic inches and the radius was 3, and then the h was unknown, what does that make? I put all that together, fairly simple number. What's 1/3 of 3 squared? So we divide that, what do we get for h? 4. That was actually really nice. They don't always give us things that are quite that nice because notice the pi's would cancel. I get 12 is equal to 3h, so h is 4. Well, that's kind of important because that means in this problem, when the radius was 3, the height was 4. We're going to use that down the line. What am I telling you the ratio of the radius is to the height every single time? It's 3/4. Which means if I have that and I come over to here, what is the rate of change of the height? So what I know is that 3/4 equals r over h, right? By the way, I did not give myself enough room on this, but that's all right. That means 3h equals 4r, isn't it? Or an r is 3/4 of an h. Is that okay if I do that? Now, by the way, the reason I did that, and that's going to kind of strike you a little bit funny, I didn't want to get rid of r. Get rid of h. I wanted to keep h. Because what's it asking for? What is the rate of change of the height? What is it asking for? dh dt. So if I got rid of h, I got rid of the one thing I wanted. Now I can backdoor my way into that answer and it's fine, but I didn't really want to get rid of that. So let's do that. So I've got, before I'm doing any calculus on this, I've got 1/3 pi r squared h, but I'm going to put a 3/4 h right there. So what happens if you square 3/4 h? I get 9/16 and I got 1/3 of that. So 3/16 pi h cubed is v. Have we done calc yet? No, we've just used what we know to be true. We've reduced the number of variables down as much as possible. So what's this thing right here when now we get to do some calc for the first time? dv dt equals, thank you, Fletcher and Jasmine and Lachlan. If you guys want to come and get that, I guess Lachlan and Fletcher, they need you right away, and yours is when convenient. So, all right. So anyway, so we got 9/16 pi h squared dh dt. So you tell me, what do we know right now? We've done calculus. Do we know dv dt? Yeah, they gave it to me. It said 28 pi. By the way, did you notice that I don't necessarily keep the units with it as I do? You can. It's actually not a bad idea to keep it with it, but a lot of times I ignore it until the end and put it back in. What was h? We figured out h was 4. Let's Problem is actually much nicer than I would have thought, because what happens that's really, really kind? Look at it. The 16s are going to cancel. Notice anything else that cancels? The pi's cancel. What's left? The only thing I see over here is the 9 and the dHdt equals 28. So what does that make dHdt? dHdt is 28/9 what? Inches per second. We're done. Hey, we just got the next problem done. What is the rate of change of the height? We figured that out. And then part C, the last part, says at the instant, let's go back down so you can see that better. At the instant when the radius of the cone is 3 inches, what is the instantaneous rate of change of the area of the base with respect to the height? With respect to the height. Ooh, that's weird. It's asking for dAdh. That's strange. Now, this should not surprise you that they would do something weird, because where are we on this AP question? We're at the end. They sometimes throw something kind of hard at us. So what was our formula for area for that base? It was pi r squared. But what do we already know? What was r? Wasn't r 3/4 of h? Does that make sense? Are you guys okay with that? I know the area is this, so if I did, careful about this, if I did the rate of change of the area with respect to the height, I should fix this. This is 9/16 pi h squared. It would be 9/8 pi h. Now I know that you're probably going to be bothered by the fact that I didn't put a dt on it because I'm doing the area with respect to the height. I'm treating height like we treated x before as the master variable. What do we know about the height though? It was 4. Are we done? So the rate of change of the area with respect to the height, the 8 came from the fact that when I did the 9/16, and I took the derivative, the 2 would pop down and make it a 9/8. So if I plug in that 4 that we've been using, it'd be 9/2 pi what? Inches, wait. Area should be, is that feet, or wait, inches squared or inches cubed? Area. It should be inches squared per, and they didn't play any games with that, so we're good to go. So that's our first, like big AP question that we've ever actually tried to tackle. Now, by the way, would you make mistakes on it the first time? Heck yeah, you would. But can you actually get some of the points? And it is pretty nice because you set up your simple little story and it actually follows along reasonably well. Okay, so wanted to go ahead and take a look at one more, and then I'm going to have us deciding how I'm going to do this today. Okay, so this is the O2 AB number 6. You notice that every year it's pretty typical that they're going to ask one of those. I'm going to start feathering in these AP release questions just to kind of see what's happening here. So in O2, they asked a question about this. So right away, what formulas or things might come into play in our story? What should jump out at you? What might come into play? Look at the picture. What do you think you might want to use on this? Would the Pythagorean theorem be a possibility? Would trig also be a possibility? Because those both study right triangles. So the ship A is traveling due west. It's going to run into the lighthouse here, right? At a speed of 15 kilometers an hour. Wait a minute. What is that? If this is the ship, what's changing on my picture right now? X. So what did they just hand me in the story? dx dt. Now let's be careful about that. They just handed me that dx dt is, careful, what is it? Thank you, Johnny. Negative 15 kilometers per hour. You guys all right? Why is it negative? Because isn't this part of the triangle shrinking as it gets closer? Okay, let's keep going. Ship B up here is traveling due north, away from it. So what is that? That's dy dt. So dy dt is 10 kilometers per hour, and it's traveling north. So is that growing or shrinking? That's growing, so that is definitely a positive. And it says, let's find the distance in kilometers between ship A and ship B when one of them is 4 and the other is 3. Gee, this was an AP question. That's not even calculus. At this moment, when this one is 3 and this one is 4, what's that answer? Are you kidding me? Distance AB is 5 kilometers. How do we know that? 3, 4, 5, because we haven't been dead in our math classes for the last couple of years. We've seen that a few times, haven't we? That was, that amazes me that back in 02, that was a literal test question. 3, 4, 5. Okay, cool. Okay, now let's do some calculus. It says find the rate of change of the distance between the two ships at that moment. Now here's what it tells me. They actually pilot these questions, they test them out, and I have a sneaking suspicion that this was a little bit of a hint, because when they tested the question, people were screwing up because they forgot it was a 3, 4, 5. So they kind of decided to give you a little bit of a hint so that you could do the next part. So if we want to find this distance, will we in fact use the Pythagorean theorem? Absolutely. So we're going to write x squared plus y squared equals, what should we call that distance? What do you want to call this thing? You want to call it z? I'm good. Z squared. So this would be 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, that was cool. Easy peasy. Notice anything nice? We've seen that. We did this last time when we saw this very question. By the way, this is no big surprise. Do you think every calculus class has some right triangles in it that you do them, ladders and whatnot? I mean, we do cones. Everybody does the same thing. Somebody walking away from a lamppost and their shadow grows. What do you know? The twos go, right? So what do you know? Do we know x? Yeah, we know x. X was 4. Do we know dx dt? It was negative 15. Do we know y? 3. Do we know dy dt? 10. Do we know z? We don't know dz dt. Can we figure that out? That was pretty dang easy. Pretty simple stuff. So I got negative 60 plus 30 makes 30, negative 30. Negative 6 what? That's weird. What does that mean then? Interpret that. The distance between them is negative 6 kilometers an hour. They're getting closer together, but this guy's going further away. But this guy's coming in a little bit quicker, so it's actually shrinking the distance between them. They're getting a little bit closer, even though this one's going the wrong direction. Now they messed with us a little bit, and there was a hint in the picture. This picture probably was not on the AP test. I will give you that hint. They probably did not have that there. They probably just wrote this. But how can I bring theta into the mix? It says, let theta be the angle shown in radians per hour. How is the angle changing at that moment, how could I bring theta into play? Let's do some trig. I don't care what trig you want. You want sines, cosines, or tangents? Honestly, I would go tangent because tangent would use just x and y, which is the stuff they handed me, right? If I go cosine, I have to use this piece right here, which is the stuff that would be based on my own interpretation. And if I screwed up, it's screwed up. So what's the tangent of theta? No. What is it? Nope. What is it? You guys are killing me. It's y over x. Don't you dare put any numbers in yet. When do we get to put numbers in? After you do calculus, okay? That's really, really important. Some of you guys will want to put it in. If you put it in, you made it a constant, and then the derivative was 0, and there's no question. We don't have it. Okay, so what's the derivative of the tangent? Secant squared theta, d theta dt. And then we come over here, and then we kind of get sad because somebody handed me a freaking quotient. And we have to do a low d high minus a high d low, and we get to square before away we go. Oh man, that kind of sucked, didn't it? Have we done our calculus? Yes, now we can actually plug in. Now you can plug in, and I do like the question that Dean asked me earlier. He goes, but man, when I tried to simplify, it was really, really hard. Can we plug in right now? This is a 3, 4, 5. What's the definition of a secant? Okay, the cosine would have been 4/5. So what's the secant? 5/4. So this is 25/16. What was x? X was 4. dy dt was 10. Y was 3. And dx dt was -15. And x itself was 4. And I have to square that. Is that pretty and simple? Not really, but it's really not that bad. I mean, so what's my numerator? I think it's 85/16. Yuck. So I've got 25/16 d theta dt is equal to 85/16. Well, there is something kind of at least marginally nice about that. We could at least make the 16s go away, couldn't we? So what does that make d theta dt? (85/25). This is the other thing that I'm not sure if they would tell you. What's the unit on that? It would be radians per hour. So this would be in radians per hour. And should we reduce 85/25? Your math teacher says yes, kind of. The funny thing is on a calculus test, AP test, if you left it at 85/25, they may wrinkle their nose, but they'll still mark you right. Because what happens if you reduce it and you screwed up in the last step? Then you got it wrong, and that sucks. So a lot of times what the calc teachers will tell their students to do is almost just to be mean, leave it in unreduced form, because you're gonna just not make that dumb mistake, especially if they don't allow you a calculator. So frequently I will instruct people just to go and smile and kind of make them play their own game. That's the game they want to play, so we'll give it to them in kind of an ugly form, and that's all good. So what do you guys think? Was that as scary as some of like the DBQs and stuff that you did back in history? I don't think that was nearly as scary as that. So I'm going to leave that for a while. Are there any other things in like AP Bio that are equally like scary? I know DBQs are the ones everybody goes, ah, DBQs.
Well, the DBQ when I took it, I was like, this is so wrong.
Oh, you did okay on it? Okay, good. Well, that happens. All right. So anyway, I think that's where we're going to stop. So can you guys do your related rates lab that I gave you? So I normally would not print it the way that I did, but I noticed that I printed it 4 sheets and nothing is back to back. So you can take the thing out and separate it out. And so what happens is you have a whole bunch of things that kind of go together. And so you're going to figure out what goes with what. So there's a story, there's some equations, and then there's some derivatives and some answers, and you're going to kind of try to figure out what goes with what. So for the next, I don't know, might be the rest of the period, looks like. You guys are going to work on that. I do have one more question I want to go through with you, but I don't know if I'm going to get to it. Okay? Actually, I have 2 more questions I wanted to do, but whatever. Yeah, you can. Please. Please the following. Yeah, solve. Please them. Talk nicely to them. Don't be mean to the question. It didn't do anything to you. Okay, Amber, how do we do?
Good, but I had a question on the homework last night.
Yeah, give me 1 second here, because